So I will speak about WASM outside my browser. I will explain why. My name is Philippe Charrière. So as you can hear, I'm French. Prepare your ear to bleed. Sorry for that. I try to lose my accent since years, but it's impossible. I'm customer success engineer at GitLab. Today, I won't speak about GitLab. It's not related. WASM is more kind of passion and interest for me. And I have a lot of side projects for that. Thank you to the Civo Navigate team, because I'm very happy to be here, even if I'm a little bit stressed because I have to speak in English. And thank you to you to be here too. You can follow me with the curious handle key33j_org on Twitter. It's the best way if you have any question after the event. So, WebAssembly. The WASM is the nickname of WebAssembly. It's a binary format that is designed to be executed on the web, inside the web page. When I say binary format, it's a WASM file, like a jar file for Java. The JavaScript virtual machine is responsible to execute a WASM module, a WASM program, because the WASM runtime is inside the JavaScript virtual machine. WASM is polyglot. That means that you can develop WASM program with Rust, C, C++, Grain language. Grain is targeting only WebAssembly, for example, like AssemblyScript, and you have Golang too. And we will have more and more languages that will be able to target WASM. And since the beginning, WASM is safe. That means the WASM program cannot do more than the policies, the security policies of the browser. Why doing WASM? So WASM is not here to replace JavaScript. Some people are saying that, but it's false. It's a complement to JavaScript, and thanks to WASM, you can reach near-native speeds with your program, so you can develop complex applications with high performances inside the web browser. And even if WASM is young, you can already do crazy things with your browser. I have two favorite examples. Who know Google Earth? Okay, so now you can use Google Earth, but without plugin inside your browser. So I didn't install anything. You just need a recent browser, and we are here today. It's very fast. I can spend a day on it, honestly. I'm addicted to map, generally speaking. And another one is the web containers from StackBlitz. So when you are on StackBlitz, you get a kind of web IDE. Probably it's the same source code as Visual Source Code. And I can run my CD samples like this. And what is magic is, even if I cut the Wi-Fi, I can run my program. In fact, the web container is a small container developed with WASM with a subset of operating system that allows to run Node.js. So for me, it's a proof of what WASM is capable. And you have other samples. For example, you can now run AutoCAD inside your browser without installing anything. How WASM works. So I try to do some nice sketch. The WASM module is loaded by the web page, and the JavaScript engine is handling the WASM runtime. So the JavaScript engine is the host of the WASM program or the WASM module. And you can develop a function like this one. This is Golang. And you can import it so the JavaScript source code can use the function like any other JavaScript function. It's very easy to use and to do. If you need to do something more than compute, for example, display something in the console of the web navigator, you need to use host function. A host function is a function exported by the host for the WASM module. So usually the WASM module cannot do anything, in fact, outside the WASM module. If you export the host function, the WASM module can use it, and then it will be able to display something in the console. At the beginning, the WASM program was designed to only do compute. So it's why normally you cannot access outside the WASM module. Now the JavaScript integration with WASM are totally lovable, so especially with Rust, Go, C, C++, and AssemblyScript. Every languages provide the wrappers and packages to develop easily a WASM application. For example, the screenshot is Golang code. So the syscall /js package is provided by Golang. And then you can create your own function. There is a JS value type. And after, you just need to use the set method to export your function to the browser, sorry. But you can call JavaScript function from the WASM module too. So it's very easy to interact between the WASM file and the JS page. And it's the same thing with Rust, for example. The primary qualities of WASM, from my perspective, there is the speed. There is the efficiency, the memory footprint of a WASM file is very small. So it's very interesting, especially if you have to load something. It's safe, as I said before. It's versatile. You can develop a large, wide range of applications from AutoCAD, game, mapping, etc. And it's portable. Because of these qualities, people want it to use outside the browser. For that, there is a new specification, younger than WASM, named WASI for WebAssembly System Interface. It's a set of specification and helpers to allow running WASM program from an operating system or from an application. So the context of running are now various thanks to WASI, sorry. And then the portability is perhaps a little bit more difficult, but the target exists. The use cases of WASI are numerous. The first one is you can do CLI. You just need a runtime. For example, WASM time is a runtime to run a WASM program. Like if you use Java --jar, --jar, the name of the jar file. You can create application with plugins. So the plugins are done with WASM. That means that you can use several languages to create a plugin for your application. For example, there is ZeLiG. It's like Tmux, but it's a little bit more fancy. You have LabCE. It's a source code editor. It's more Rust dedicated, but you can use it for other language. Some databases are starting to provide the ability to develop user-defined function with WASM, like ScyllaDB, but there is, I think it's in beta version, but you can already do it with PostgreSQL. Some company like Webhook Relay allow you to create webhooks, but in WASM, so you are sure that it is sandboxed, and it's very important for security. You can develop filters for Envoy. Envoy is a proxy. Usually you develop the filters with Lua, but since some months you can do it with Wasm. And another use case is function as a service. And for example, you have Fermion that is providing a platform, Wasm Cloud 2, Shopify. In fact, Shopify provide a feature that allow you to run JavaScript inside the Wasm module. So you lose the speed, but you gain the security, and they are sure that their customers are not doing some bad thing inside the module. And there are other use cases, and probably we will see a lot of more use cases in the future. So even if the WASI world is young, sometimes it's difficult to find your way. So I try to do a map, an ugly map, because I have no talent for design. And I list some territory in the map. So for me, the first territory is the WASI runtime territory. There are several projects like WasmTime, WasmEdge, Wasmer, Wasero. Even Node.js is providing WASI runtime. And except for Node.js, every runtime provides a CLI to run Wasm application and a SDK to create your own application, and your application will call Wasm function or Wasm plugin. You can call it as you want. A first demonstration. I did a simple program with Golang. Is it readable for everyone? Okay. So it's a very simple program. I just display a message. As you see, I love emoji. I get the arguments. I will wait for the sentence, and I will display something. For that, I use TinyGo, because in fact, Golang cannot build a Wasm file with the WASI specification. It's in progress, but right now, if you want to use Golang to do WASI, you have to use TinyGo. I already built it. So I can run it with WasmTime. WasmTime is Wasm runtime. You see, it's very easy to do, and if I can change of runtime using WasmEdge. And I can do it with all the Wasm runtime, of course. The last one is with Node.js. You need to use the flag, the experimental flag, and you have to write a launcher with JavaScript. The launcher is very simple. The WASI package is already embedded inside Node.js. I create a WASI object to pass the argument. Then I load the Wasm file. I create an instance of the Wasm runtime, and then I can start my Wasm program. So this is this one. No. So you can have several runtimes with the same Wasm module. And again, it's like when you use Java with a jar file. So create a CLI application with Wasm compliant with WASI, it's easy. But create an application running Wasm plugin, it's harder. Because for example, when you start a new language, you start to learn a new language, you want to do a hello world, but with WASM you cannot use a string as a function argument or as a return value of a function. So you need to use the SDK to write some helpers to do that. You cannot access to the operating system, so you need to write some host function. But if you use 10 languages, you will need to develop 10 helpers. Today, there is no debug, so it's not easy to develop. This is in progress. The specification is very young. So if you want to create an application with WASM plugins, you need to develop all the plumbing with the SDK. I will try to explain the string issue. When I said to my friends that I will speak in English in Florida, they told me, stay simple, don't do demonstrations, so I will do the opposite, and we will see. I call it the boring part because the first time I have to understand how to do this, it took me several weeks, but now I can reuse, of course, my helpers. So when you create a WASM function, you think that you can do this. Just have a function with a string parameter and returning a string, but with WASM, you cannot. With WASM, you can only use numbers, and you can only return one number and not several values. So to pass a string to a WASM function and to use the WASM function to return a string, you need to play with the WASM memory. The WASM module share a buffer memory with the host. For that, if you want to create a WASM function and to use it to pass a name, you need first to copy the name inside the memory. You will get the position and the size of the string, so you will use it as argument of the WASM function. Once you have that, the WASM function is able to read the memory because it has the position and the size. You can create your return value. In this case, you have again to put it inside the memory to return the position and the size of the string inside the memory. And you need to return this position and this size, but inside only one value. It's the moment where I was alone and I didn't know what was bit shifting. So I have another talk to explain that, but I did business school before computing, so I have some lacks of low-level programming. So for me, it was a big discovery. When you get the packed value, you will need to do bit masking to split the value and get again the position and the size and read the memory and get the return value. You haven't to do this every time. You just develop it one time and after use it. The specification is in progress, so I hope soon we will have more complex types like strings, of course. But there is another territory. This is the WASI toolkits. And for that, the toolkits is doing the plumbing for you. You don't have to develop these weird things. And then with the technical frameworks or WASI toolkits, you can develop application and plugins. For that, you have already XTism. Microsoft is providing a very nice SDK. You have E2Core from Suborbital and other projects. These projects are using the SDK runtimes. So they use WASMTime or WASM Edge or WASMer. E2Core can use every WASM runtime. There is another territory. This is the host application framework. In this case, it's very opinionated because the framework is providing the host runtime application. Most of the time it's web application server, and the WASM module is your web service. So in this case, you only have to develop the plugins and not the application. I will do another quick demo with WASM Worker Server. It's a project from VMware Octo. It's a small HTTP server. The WASM workers are the WASM module and are small microservices. We can call it nano services. And you can run it almost everywhere. So next demonstration. This time with WASM Worker Server, right now you can do plugin with Rust and JavaScript, I think, and more in the future. So I did a very simple Rust code. In fact, you use the WASM Workers library, and you just have to create a web handler doing your payload, for example, and returning something to the HTTP client. I already built it, so I will serve it. So in this case, I only have to develop the module. So now I just have to. Where I am. Never mind. So you see, it's the beginning of a little function as a service with only one function, but you can pop the server every time you want. And this kind of application, for this kind of application, you have Spin for Fermion. They are providing the same kind of thing, web application server, but for Golang, Rust, assembly script, JavaScript, I think Python and PHP, but I'm not sure. It's the same for E2 Core. For WASI ASP.NET Core Server, it's only for C#. And Capsule, it's my side project. It's only for Golang right now. And don't use it in production. There is another territory. For me, it's the platform frameworks. Every project providing a host application framework, most of the time provide a platform like WASM Cloud from Cosmonic, Extension Engine from Suborbital. So every platform is here to host the host application and the WASM module. You have Fermion Platform and Fermion Cloud. Fermion Platform is the on-premise version of Fermion Cloud. So you can install it where you want on a laptop. It's okay, and it works like a charm. And of course, the last territory is the application territory. It is everything you have in mind and you can develop with a lot of use cases. To be honest, my favorite territory are runtimes. Even if my low-level programming skills are too small, I really like to use the runtimes part, the runtimes SDK, and the technical frameworks. Then I will speak about my silver bullets to free WASM from the browser. I use WASZero and or XTSM. WASZero, it's a runtime that is targeting only Golang application. You can create the WASM module with the language you want, but for the host application, it's only with Go, and there is zero dependency. I will show you a small demo. The source code will be provided, so I won't explain all the helpers. I explained it before with the string slide. It's a small Golang HTTP server. I did a Wasm plugin with TinyGo, and the HTTP server will serve the Wasm plugin. And all the plumbing was done before. So my web server is very simple. I will load the Wasm module. I start an HTTP server with Golang. It's providing by I think, the net HTTP package. And I will trigger the HTTP handler at every HTTP request. So in my HTTP handler, I will read the payload of the post request. I will instantiate a Wasm runtime, so the Was0 Wasm runtime. Then I will instantiate my Wasm module. I will get a reference to my function. I will copy inside the buffer memory the name I post with the post request. And then with that, I will be able to call the function, the Wasm function. As argument, I will post the position and the size of the string. And then I will be able to read again the memory to get the position and the size of the result, and to reply to the HTTP client. The web function is very simple. So when I call it, with TinyGo, you need to add this remark, export the name of the function, to make the function visible or exportable for the host. I read the memory with the position and the size. I get the name, so I transform the buffer in a string. I create my return message. I copy it inside the memory. And then I will be able to pack the position and the size of the message in only one value. It's why I spoke about bit shifting in the previous slide. And the helper in the host application will need to do bit masking to split the value in two values. So to run it, so my web server is listening, and I can query it like the Wasm worker server in the previous demonstration. Once you understand how to write the helpers with Was0, it's very easy to do a host application, and the team of the Was0 project is very friendly. They take the time to explain you when you have a question, and the documentation is pretty good. And the source code is really readable. XTSM. So it's a toolkit. With this toolkit, you have two SDK. A SDK to create host application, and a PDK to create Wasm plugins. You can do it with four various languages, and it's very new, but you can create Wasm host application with Java. So it's very interesting because GraalVM had the promise to do that, but it's in progress, and they didn't do really some progress, and the documentation is almost empty. So if you want to do Wasm with Java, XTSM is a good solution. And for the plugin, you can create the plugin with C, Go, Rust, Haskell, AssemblyScript, and even JavaScript. They use the QuickJS project, and they embed it in the Wasm module. So I will show you a new demo. It's almost the same thing as the previous one, but for the HTTP server, I use my favorite Java project, Vertex, and I will run 3 WASM plugins, one with TinyGo, one with Rust, and one with JavaScript. So I will spawn 3 HTTP server to provide to host my function. So the Java sample is a little bit more verbose. It's Java. So there are packages from XTism. So everything is ready to use. You load the WASM file. I put everything inside the environment variable. You create an HTTP server with Vertex, a router, and a route, and then a route handler. Every time I will do a post request, the handler will be triggered. I will get the value of the payload. Then I will be able to instantiate a plugin and call the function of the plugin and then return the value to the HTTP client. And the functions are very simple. This is the Golang one. So XTism provide everything to read the memory. And then when you create your return value, you can allocate a place in the memory for the string, copy the string inside the memory, and return 0. It's just because you need to return something, but the host application will read the memory and not the 0. For the Rust version, it is simpler, in fact, but it's the same logic. And for JavaScript, where is JavaScript? You just have to create a function, read the memory, write the memory, and return the value. So to run it, I will start my server 3 times. I think it's okay. And then I can call my free function. So you can, how many? 5? Okay. You can start a kind of function as a service very, very quickly. And with Vertex, it's a real pleasure. So, what else? We are seeing a kind of convergence between the WASM runtime project. And so, for example, now WASM Edge decided to implement the socket API specification like WASM time. It wasn't the case before, but now it means that you can use the socket directly inside the WASM module. And if it runs on WASM Edge, it will run on WASM time. There is a POC done by WASM Edge, sorry, and Docker to use the WASM file or the WASM module as a container runtime. So without the classical container and only with the WASM runtime. So it means that the footprint will be very, very, very light. You can already enjoy the fact of using WASM in Docker and in Kubernetes if you use the Scratch image. For example, I use my side project, Capsule. It's a WASM runner, and you can use it as a HTTP server or MQTT client or NAT client. The runtime, the size is around to 17 megabytes. The WASM module is around 158 kilobytes. So my Docker image at the end is around 18 megabytes. So it's very, very light. And if we'll see if I'm able to do it in less than 3 minutes. I have a Civo cluster. I already built my Docker image, so I will deploy it now. I think everything is okay. You see, it's pretty fast to have a running container. And I will scale it how many times? 30 times. So if I So to have 30 pods on Civo, it's really fast because Civo is fast, right? But because my container image is very light. So I think don't wait for Wasm as a container runtime. You can already start with Wasm. And now I have my 30 pods that are running. So you see, it's very easy to do. So I would say start learning Wasm now. It's important. And you can already deploy Wasm services on Kubernetes. I put some links. If my source code is not clear, don't hesitate to ping me on Twitter. This is the code bar for the deck. And if you have some question, but as I said, only the easy question, and speak slowly, please, you can now or after outside. Any question? No question? Because I said only the easy question. Yes?
So passing direct memory addresses and space, is that the only way to get out of these functions?
Right now, yes.
Right now,
but it will change because there is a spec, but the spec is changing a lot.
Yeah.
They don't do anything, but the spec is changing to define a specification about complex types. So at this moment, it won't be a problem anymore.
It seems like a potential issue.
Like directed.
Is there any solution in place right now to avoid using the same memory address? Like, put something back again? I've noted that putting it over the other variables.
Yeah. It could be a potential issue with the memory, but in my case, I reinstantiate a new module every time, so you start with a new shared memory. So I tried to do another way, but it was a mess. And in this case, every time it's a new part of the memory, and you have no issue with that.
So does that also explain
Trying to, oh, sorry. We were talking about memory and security here and the way that works. So does that also insulate like those WASM functions from affecting the host processes?
The Wasm share memory is only for the host and the Wasm module. The Wasm module cannot access to something else.
Okay.
It's a very sandboxed.
I understand. Thank you.
Except if you create your own host function and you allow to do anything. But usually, there is no security issue.
Okay.
And no security, no memory issue.
So the two WASM functions wouldn't share the same memory?
Sorry?
If you had two WASM functions, so you start up a server,
Not the same memory.
Two endpoints?
Every instance of Wasm function has its own place for the memory. Or if you have three instance of the WASM function, you will have 3 buffer memory,
Okay.
not only 1. I think you can share 1, but it would be tricky to, I'm not sure.
Yeah, that's really where my mind's going, is like all the potential like
For me, it's-
security implications around managing memory in this way. Yeah.
For me, it's different place in memory for every instance.
Okay. Thank you.
Thank you.